All right, in this session, we'll be working through NeetCode 150, and today's problem is valid anagram from the arrays and hashing category. And so the problem statement is, given two strings s and t, return true if the two strings are anagrams of each other, otherwise return false. And an anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. So we're given two examples. Example one, our input strings are S and T, where race car and car race are in fact anagrams of each other. You can pause the video and count the amount of characters for each string, but in this case we return true. For example 2, we have S and T, where S is jar, T is jam. Obviously, J and A are the same, but R and M are not. So in this case, we return false. So as we think about solving this problem, we could compare S and T, but obviously the order is different. So what we want to do is we want to count the number of characters for each string. And if we try to solve this problem in a rather Pythonic way, there happens to be a very useful data structure, a built-in data structure that we can use in this solution. So we'll go ahead and do that. So we'll go ahead and import counter. So from collections, import counter. And so counter happens to be a special type of dictionary that will count the frequency distribution of characters in our strings in this case. So I'll go ahead and set up a counter for S, and thus I'll call this SC, and I'll do the same thing for T. So TC is a counter for T, if I can type. And so, again, this is a special type of dictionary. It will count the letters for us. And in dictionaries, order does not matter, right? So if we compare SC and TC, given that we in fact have anagrams, then this should evaluate to true. So we can just do return SC equals TC. Let's go ahead and run that and see if it works. So it passes the two test cases. Let's go ahead and submit. Amazing. All right, let's go ahead and check the complexity. So we see that the time complexity and space complexity are linear, so O of n, which means that the solution is rather efficient as a function of input, which is awesome. Well, thanks for hanging out, and I'll see you in the next one.